I'm Jeff Smith. I'm the Chief Technology Officer of Numerex. Numerex is a 22-year-old company, been public for 20 years, pure play M2M company since its inception. Originally, it was called Telemetry Company. We have about 2.5 million devices on our network. We're adding one about every 45 seconds. And the difference that Numerex has relative to a lot of the other platforms that you've looked at is that Numerex really does the device, the network, and the application. But before I start this presentation, if you don't mind, since we're a public company, I need you to read the safe harbor statement and sign a non-disclosure, et cetera, ad nauseum. Here we go. So the Numerex ecosystem includes four primary areas that we do our business in. One is the security solutions area, the second is asset ID and tracking, the third is supply chain, and the fourth is remote monitoring. So what I'm going to do today is give you some demonstration of the platform at the device, the network, and the application layer. And then we're an enterprise managed services company that develops applications for our customers using those platforms, and in some cases enabling our customers in order to enhance the platforms their solutions with the platform itself. So we talk about the Numerex DNA, device, network, and application. One of the things I want to mention, though, at device, network, and application is that you really have an onion model. And that onion model is really the reliability is important, the performance and scale is important, the analytics and the status, and then, of course, some kind of adaptation capability, because, as you know, sometimes, for instance, the network gets a little constipated, and then all of a sudden things stop working for a while, and then all of a sudden there's a huge rush in. And so having an architecture of a platform that enables you to both use a private cloud, but then enhance that with things like OpenStack technology to be able to spin up a number of instances outside in the public cloud network in order to take care of in-rushes of data and things like that is very important. One of the things I also wanted to mention was that a lot of people from a platform standpoint don't talk about operations and development, and the DevOps concept is a very important concept related to software as a service models. And if the companies don't have a capability for DevOps, you're not going to have that level of scale and reliability that you need when you do deploys of large numbers of devices. And so from a software standpoint, you need a build process. It probably needs to be agile. You need to be able to put things out from an versioning standpoint. You need a packaging capability and deployment. You need staging servers and the production servers and a methodology to be able to move those through. And it's changing the wheels on the bicycle as it's going down the road. You need to be able to do that with zero downtime. It's important from a platform perspective. From a servers, you have the provisioning, the configuration, the deployment, and the performance testing. You need to be able to do load testing on things to know when the elbows are, know where you can do things like adding additional servers in order to add additional capability or to do load balancing between servers that you already have in place. And then from a sustaining standpoint, you need to be able to do maintaining, monitoring, upgrading, the recovery process, and also performance improvements. I'm going to talk about this system from a device, network, and application standpoint relative to the bullseye. At the middle of the bullseye are the sensors, and then you have the devices, the network, the gateway, the services, and then the application layer. And then really there's the capability for optimization around that with using things like big data. We capture about 3 to 6 terabytes per month. We do about 3 billion transactions per month on our network. And we capture every single packet that goes across our network and analyze it in the cloud, in S3, and on the Amazon cloud. So, diving in very quickly, we have a system with a large number of sensor capabilities. They're third-party sensors, but they're compatible with our short-range wireless capability. These are some of the ones from Monit. Here's another system of sensors. You can tell there's about 150 short-range wireless sensors that are able to sense information and send it back to the device. And in the device side, we'll go to, we have lots of devices that are compatible to the network. We build translators quite quickly and have done it for a long time. But in addition to devices that are on our network, which are third-party devices, we also happen to develop devices internally and manufacture those devices itself. And I'll talk about one specific application relative to those devices. We have the NX device platform, which has basically a capability for GPS and cellular. You have add-on capability to be able to do satellite-type transmissions, both one-way and two-way, that we're working on in order to add to that platform. But from a platform standpoint at the device side, it's not just the electronics, it's really the packaging also. So one of the things you see on the right-hand side of this particular diagram is the capability to take this particular platform, which is IP67K rated, which, you know, you can immerse in water, you can spray it with high jets, it's very environmentally protected. You also have the capability to change the top cover and be able to put on another top cover that actually has wired capabilities instead of wireless. This particular device platform, 4 AA batteries, can last 4 to 5 years, being able to transmit back a few times a day and be able to give location. It has an accelerometer to know whether it moves for shock and vibration. It has GPS, it has short-range wireless. And in fact, it has such a great battery capability within the operating system that it will last a long time from sensors that are also wireless in a platform. So I'll show you an application in a minute where you basically take this and injection mold it inside of a plastic pallet, and it'll last the lifetime of the plastic pallet. This particular platform, by the way, also has the capability of not only purchasing this particular device off the shelf, but you also have the capability to be able to just buy the board. And so if you have your own mechanicals, you want to be able to insert the board in, you want a fully PTCRB and FCC ID certified product to be able to put in there in order to shorten your time to market, you can do that. Or just license the schematic from us and implement the schematic. Now, this isn't the schematic. This is actually a schematic of a Fender reverb unit that I had, but I just grabbed it and put it onto this slide. The NX... I'm getting punchy this time of night, you know. The NXOS architecture is the operating system that's basically on that device. That operating system is specifically designed for the M2M world. And so what you see in the capabilities of this operating system, you have capabilities like things like being able to speak directly to GPS chips that are on the board or other GPS chips. You abstract the user away from that. But really, you don't have to get into the weeds like this in order to program this. I demonstrated yesterday in the little bake-off that we had last night in the reception. I demonstrated this, which was actually programmed in a scripting language, JavaScript, down at the device layer. So we have a small single-chip microcontroller. It's a very low-cost unit, but it also has the capability to be able to be programmed in JavaScript, which, if you have programmers that are programming at the application side in JavaScript or programming on mobile devices in JavaScript and HTML5, you basically have a consistent way of programming, which is very important when you're trying to be able to do efficient programming. The NXOS also has an API, and you'll hear API 3 times in this particular presentation. We have an API, web-based services, all RESTful, that configure directly into the device. We have ones that go directly in order to do provisioning, billing, and other information relative to the network. I'll talk about that in a minute. And we also have an API at the application layer. Obviously, if you want to go into the gateway and be able to do reliable transmission, you want to be able to do it at the API layer so you can use your own back-end enterprise systems or your own software development using a different development environment. So then if we move up into the network layer, we have a full network suite. We in fact have all of the network elements except for Spectrum. We also partner with most of the large network providers around the United States, Canada, and Mexico, and have a portal in this particular case and a platform at the network layer that allows you to be able to not do the swivel chair across networks, but in this particular case, it's also a hybrid capability. So not only are you able to manage the network from the same portal, you're also able to manage the devices, the device management, firmware over the air, and also the application, how the application's hosted, whether it's in the private cloud or the public cloud. And so you have a common interface to be able to move through the platform and do optimization and things like that. We have a network with all the network elements, as I said, from the GGSN and HLR and all the 3- and 4-letter acronyms that you hear relative to this. And that's important sometimes in application deployments because you want to be able to have, for instance, a long-life battery asset. Well, that means that when this thing first transmits back to mothership needs to be able to respond back and say, I've got the information, go back to sleep as quickly as possible. If you have the network elements, you can actually have the HLR. When it registers on the HLR, you can automatically then, or it goes to the GGSN and makes the connection for the P2P context, you can automatically then send a web service call back to the application, and then the application can stop transmitting back down. These are some examples of the API at the network management layer. Then you move up the stack a little bit, and you start seeing the network diagram relative to the gateway and the gateway layer. And at that gateway layer, you have the capability to be able to also move into an API. So at the gateway and services layer, you have APIs that have to do with reliable transmission. And remember, it's a hybrid network, so you have the ability to be able to transmit via things like UDP or SMS. You also have the capability to move through satellite transmission or cellular transmission or Wi-Fi transmission, and all of that through SIP programming and SIP in diameter signaling context has the ability to be able to do roaming across those types of network elements. And that's important to have the network elements from a platform standpoint so you can do that level of visibility and roaming across the network. So this gives you an idea of some of the gateway and services. Down at the bottom, you'll see curl commands. There's a really nice interface to be able to try things out, sort of test things and send information to the device, get information back while you're developing the application. And that's an interface both to the gateway and also to the services layer. A lot of the things that happen in the application layer really need to be at the network layer. And at the services layer is one of those. Services like, for instance, reverse geocoding or geofencing. Not a lot of times people do geofencing and complex geofencing at the application layer, which doesn't make any sense at all, particularly when you have deployments in our case where you have hundreds of thousands of devices that are transmitting back locations on a 15-second type interval, and you have to be able to do complex geofences in real time. Quickly, the application programming interface has the capability to be able to, and we have written example programs in C, Java, Node.js, and Python, and a few other languages to be able to give you sort of a start way to go in and program at the application layer from an API standpoint. If you move up to the application layer itself, I'll give you just a quick example, and then I'll give you some very specific use cases of some deployments that we have. But just to give you an idea, some of the applications that we've written, you know, and it's interesting because in the applications of the MDM world, what's interesting to me has always been that if you stand back, you squint your eyes a little bit, and you look at the applications, you find out that they all kind of look the same. And so having a robust API interface and a robust library of software and things like that enables you to be able to create these types of applications with things like dots on a map and listings and things like that very, very quickly. But it's not only the application side, it's also the device management side, and it's also the administration layer. So security and administration and those types of things are all built into the platform so that you can quickly and reliably create these types of applications on the fly. These are the ones I save for last because these are the boring applications. These are the MTM applications, which are just basically listings on the side. And then you move into the mobile applications, and as I said, JavaScript on the application, JavaScript on the device, JavaScript on the mobile application. So in this particular case, it's HTML5 with JavaScript. And then if you go into the last part of the presentation, that has to do with actual deployments. This is a deployment for Sure Response that we do for Verizon, which has a purse system, which is one of the areas that we do a lot of work in. This is another purse-like device, except in this particular case, it's on the Sprint network, and it's distributed through Sprint stores. And this device is for kid tracking. This device here is by Reliant Heart, which is when you get a heart transplant, in a lot of cases, you need left ventricular assist, and this is a device where we basically help them do the radio implementation inside a device that previously was not wirelessly enabled. We wirelessly enabled the device, we provided the network capability, and we provided the application which allows for EKG to be able to be read remotely by a doctor. In this particular case, this is one of the use cases where I wanted to talk about ROI. In this particular case, ET Water wanted to wirelessly enable their irrigation systems. And so putting a cellular board, like I had described, inside of this particular irrigation device enabled ET Water to be able to put large numbers of their customers back into compliance, particularly in the Southern California area, where you have fines of up to $10,000 and in some cases $30,000 for water runoff problems. And there's a particular use case where 323 water monitors were put into place, and on those 323 water monitors, the problem was solved. It turns out that 20 to 50% of water is actually wasted. And so there were three different reasons why they saved money in this particular case. One was they used less water. Okay. The second was that they actually did not have to do manual control of the irrigation system, which saves them on a per 323 units, 20 minutes per month. And in the third case, they had the capability to be able to not get fined by the Southern California. And the payoff in this case was in less than a year. We also do car connection for AudioVox distributed through Best Buy and also Walmart. We also do the ScramNet, which is this is a system called Alcohol Monitoring Systems. And in this particular case, we helped them wirelessly enable the alcohol monitoring system, and also did the network side, and also did the application. In this particular case, we had a company that was doing tank level monitoring, so we wirelessly enabled the tank level device. We also did the network case. In this case, it's both satellite and cellular, so it's a hybrid device. And in the case of the tank management reporting, it was also on the web. And this case right here is we do a lot of things that have to do with offender monitoring. In this particular case, there's a device that we manufacture ourselves, which is an ankle bracelet. And so we provide the ankle bracelet, we provide the network capability and monitoring there. A lot of very sophisticated things at the services layer that have to do with location and a Kalman filtering algorithm to be able to do very sophisticated, when you get cruddy information from lots of different things, and you get a pretty good location inside relative to doing this sophisticated Kalman filtering algorithm. And then, of course, we have the application to be able to send information back both to a portal and also to a iPad or iPhone or Android device. And in this particular case, we do a lot of things in the security industry. We have, it's part of our infrastructure and part of the platform, is actually two-way voice and video. And in the two-way voice capability, basically what happens when you have a security event, you can't call from the house because you'd have to do 911 for that in a cellular telephone. So what happens is you have out-of-band signaling, typically through SMS or through a broadband adapter, through Wi-Fi in the home. And then you have the capability from the central system, our platform, to make two phone calls, one to the central monitoring station and the other one to the home. They marry those two calls in a PBX-like fashion to be able to have a confirmation that something's actually happening in the home. Yep. Okay, got it. We also have a video infrastructure in the middle, which allows us to be able to do little snippets of video. And the last two slides that I have here have to do with optimization. As I said, we do big data analysis on all the packets that go across our network. We do that primarily to be able to reduce the costs for our customer relative to their infrastructure costs from a wireless connectivity standpoint. I call this our tadpole chart. And in the tadpole chart, what you can see is that we try to drive down. Every one of the little increments is actually a week's worth of data. And as you can tell, we're trying to drive down for our customers the actual cost of their SS7 charges related to the messaging traffic that goes on within their company. Thank you very much for your time. Let's go have a drink.